Hello everybody, it's day 18 of our astronomy unit. I'm Andy Pilc, and today's lesson was on dark matter. So I made a little presentation based off of a lesson that I gave to some teachers a few years ago, because dark matter is something that really is at the forefront of space science right now. We do kind of know more about what we don't know about it than what we do know about it. But in this video, I'll kind of go over a brief history of how we came to know what we don't know about it and what we might come to find out about it. So, a brief history of matter and gravity. Way back when, thousands of years ago, the ancient Greeks used to believe that everything on Earth and everything in the universe was made out of the four classical elements, so fire, earth, water, and air. And Empedocles was the thinker that was kind of behind that thinking. Around 400 BC, they started shifting their thoughts. This Greek thinker Leucippus had this idea of atomism, meaning that everything in the universe and everything that we can see, touch, taste, smell was made out of these really tiny components, which he called atoms. And he turned out to be right as we got microscopes and learned how to study things on a microscopic level. In the 1600s, you know about Isaac Newton. He came up with his not discovery of gravity, because of course things still fell before he came around to describe it, but he made those mathematical equations that started explaining how things are in orbit in space and how things act on Earth, and he gave us the discipline of physics. You can't talk about physics without talking about Albert Einstein. So in the year 1916, he published his idea of special relativity and deepened our understanding of how gravity and matter and light act. And in the 1930s and 40s, there were some other thinkers, most notably Fritz Zwicky, who did some research and discovery around dark matter in the universe. So just to kind of discuss what happens to light as it travels through different mediums, to talk about, or to rather maybe describe what dark matter is and what dark matter isn't. So if light leaves a light bulb and travels to your eye and travels through nothing, through open space, then that photon of light would travel right to your eyes, and you would see it as is, as it left a light. If that photon of light has to travel through water, you may have experienced this when you put your finger or a straw in a glass of water and you look at it through a glass. You'll see that the wave of light bends a little bit as it travels through that medium. If the light has to travel through maybe a cloud of gas or dust, then the light would still get to you, but maybe it'll be a little bit dimmer, it'll be a little bit harder to see because some of that energy, some of that light got absorbed by the atoms inside the cloud of gas or dust. So a black hole, by definition, is something that is so massive that the physical beam of light couldn't escape the black hole once it crosses the event horizon. So because of that, when light goes through a black hole, it goes in and it doesn't reach your eye, it doesn't come out, it doesn't get past that point. If light were to leave, or rather, if light were to leave this light bulb and then travel through dark matter and reach our eyes, absolutely nothing would happen to that beam of light. So that's what kind of makes it a little bit tricky to actually put our finger on what exactly dark matter is. We know that it's out there, we know that it's interacting with some things in space, but when it comes down to actually seeing it and touching it and proving that it's there, this is not the way that we can prove it. So scientists have come to the conclusion that baryonic matter, or all of the matter that we know that we can sense with our senses, comprises about only 15% of the known universe, and 85% of the matter that's out there is dark matter that we can't figure out how to see it. So that actually lends itself to learning about string theory and other theories. Before we get into that, or we won't get into that in this video, let's talk about the three pieces of evidence that we do have that support the idea of dark matter. So the first one has to do with galaxy rotation, meaning that the galaxy is spinning at a speed which all of the stars inside of it should be thrown from the center due to their centripetal force, due to the centripetal acceleration. If you've ever been on that gravity ride, the gravitron, where it spins really fast and presses you against the outside of the gravitron, that's pretty much the concept to think of here. The stars of the universe or of the galaxy should be ejected into space, but something is massive there that's holding it in. So we think something is there, and we think that stuff is dark matter. The second thing has to, again, do with galaxies and their behavior and the way that they've clustered around. So a lot of times astronomers can watch the behavior of two galaxies as they merge or as they collide, and you can see these simulations if you look them up online. But the way that the stars and the galaxies act during those collisions make us think that there is much more mass there, generating more gravity than we can account for when we're looking at the brightness of these galaxies and we estimate how many stars are there and what the mass of the galaxy is. It turns out that the galaxy should be much, much more massive in order to generate the gravity that it takes to have them act the way that they do. The third piece of evidence is known as gravitational lensing. And if you've seen that picture of the black hole, you'll see how light will actually bend around the black hole because of the gravity. So any light that doesn't necessarily enter the event horizon, it'll bend a little bit because of the gravity, but it won't be brought into the black hole. So if we look at very, very distant galaxies and we look at them as they pass behind other galaxies, then we can expect a certain amount of what they call lensing, which is the distortion of the galaxies as they are visible to us here on Earth. And the amount of lensing that's occurring doesn't add up. There must be much more mass in the galaxies in between what we're looking at in order to generate the amount of lensing that we're seeing in those distant galaxies. So those are the three pieces of evidence that we do have for dark matter existing. And the actual existence of dark matter is still a little bit confusing to astrophysicists. So it's going to take a new, brighter, young student to study these things and make new discoveries in order to add to this. What's going to come next? We're not sure, but we're still trying to figure that out. Hope you found this video interesting. That's all I have for today. I'll see you folks next time. Have a nice day.